Okay, so why don't we get started? So we're already officially in week four. Week four, we're going to start talking about repetition, how to make your program repeat certain statements or lines of code a bunch of times if you wanted to. What we covered last time was repetition, and let's have a look at that real quick, just like a quick review from last time. Okay, so last time going over these things, third time's the charm. Your relational operators, very important, which are used to create conditions, which are ways for you to check to see if something's true or false, so that your program can make decisions and select between certain lines of code and others. How you could use an if, else, right? The difference between having an if else chain, like this one for example, and having an if else, right? So you noticed last time the example that I gave you was this else right here will automatically happen when this one's false, okay? Same with this one, but this one will be basically the last thing to happen. So if this one here is going to happen only if the previous two things are false, then this one here is going to happen only when the one thing before it is false. Okay, so it doesn't matter whether this is true or false, we're still going to go check this, and only if this is false we're going to do this. Versus the other example underneath, we check to see if this is true. If it's true, stop here. If it's false, go to this one, see if this is true. If it's true, stop here. Otherwise, you go to the last one, which is like the final thing that's going to happen. Okay, if has a condition, right? Whatever's indented underneath the if happens when the condition is true. Similarly, the elif has a condition, except you can only have an elif after an if, right? You cannot start with an elif, right? So this is bad. And that's basically it. Other thing that I covered was how to make a random number. You have to say from random import randint, and then this randint function generates a random number between 1 and 3, and you're going to learn what functions are in a couple of weeks. And how, if you have a condition, to make sure that you compare numbers to numbers, because if you're comparing a number to a string or a string to a number, that the comparison is not going to work. Okay, and this issue arises whenever you have some kind of an input and you forget to put int input in front of it to cast the input into some kind of an integer or float input, right? As long as it's some kind of a number, whether it's a integer to integer comparison or integer to float, float or integer, as long as it's a number, it works fine. But if you're trying to compare a string to an integer, it's not going to work. You can compare string to string. Right, so I can either say int here to turn the input into a string, or I can just say, well, quotes around this thing to make it a number in order for my comparisons to work. Okay, what else? So yeah, this is the way it should be done. And what else? Oh, the ORs, right? So these are the logical operators, or, right, which is used to check to see if something is outside of an acceptable range of values. It's also used just to build logical statements in your program. Okay, and the truth table for that thing, for the OR, basically it's true anytime both of these are not false, right? So as long as both of them are false, it's false. Any other case, when you have two truths or one true, the whole thing, the whole condition with the or in between, or the whole statement is true. And then there was also an and, right? I introduced you some nested ifs, right? So you can have an if inside of another if. Just be sure that you don't start with an elif, because it will be the first thing that's inside the if. So if you start a new indentation, you have to start with an if. Can't start with an elif, okay? And another way to rewrite this is using an and, right? So the and is kind of sort of like an nested if. Logically, speaking, and you have your little truth table. This one evaluates to true only when both of them are true, right? So if either one or both of them are false, then the AND, the two conditions with an AND in between, evaluate to false. Okay? Some examples in there, some hints, right? Formatting output using the percent point 1F, right? Rounding numbers. And some more hints in there for the rock, paper, scissors game. And then the zodiac thingy. All right. A little bit about accumulation. What was accumulation? You basically start a variable at some value and you keep adding up to that original value, right? So when I say num is equal to num plus 1, that's the same as saying you are equal to your old value plus something else. It doesn't have to be plus 1, could be plus 10 if you want, right? The shorthand notation for this is plus equals, so you can either write it this way or you can write it this way, same as we can write this thing this way, or you can also write it this way, okay? And it also goes backwards. If you want to go in reverse, if you want to go minus works the same way. If you want to do it this way, you can do it, or if you want to do the minus equals, that also works. And it works the same for, you know, different numbers, right? If it's a 10, you do minus, well, yeah, there you go. And what else? In here, finding the sum of all numbers takes advantage of this accumulation business. So basically you start some kind of a variable sum and you keep adding to that number. You keep adding all these other numbers to it, right? You can do sum. So instead of doing this, right, I can either do this, and also the equivalent for this is I can say, all right, well, this sum all plus equals A, and then sum all plus equals B, and then sum all plus equals C, and then the last one, sum all plus equals D. Right? So whether I write it this way or I write it this way, either way is fine. Okay? Either way is equivalent. Okay? And using that same principle, we created a variable sum neg, and if one of these values, or if any of these values are less than 0, then you add them to the sum neg. So this will be the sum of all the negative numbers. And that was it. So this is basically your review in a nutshell. Everything that we've done up to this point, pretty much, as far as selection is concerned mostly. And this accumulation business is very important because this is how you would be counting things. Right? So later on, when we start learning about lists, as soon as I introduce you to repetition, which is making the program do something automatically a bunch of times, then I'll introduce you to lists of numbers, and then you can go and look through the list of numbers and search for like a specific value and count how many times that value appears, right? And the way you would be counting is this kind of stuff, using this kind of things. Okay, so this accumulation comes in handy all over the place. So get comfortable with it. All right, so that's that. And what we're going to do today is repetition. So if I go to, that was week 3, practice with selection. And now I'm doing week 4, repetition. And I already have the old video from the summer in there for your reference if you want to watch that. Probably be just as good as the one I'm going to do today. Maybe not. We'll see. And then some hints in there for all the different assignments. I wrote them up in case, you know, the videos and the notes don't make sense. Then you have some hints in there. Don't look at the hints unless you absolutely get stuck, right? And even if you get stuck, don't look at them. Just try to solve it on your own. And if you're like hit a wall and you're like, all right, I can't do that. I have no idea how to do this. Then look at the hint a little bit, okay? And the best thing to do is, if you have to look at the hint for one of these assignments, you should try doing the assignment again without looking at the hint. So you finished it, you wrote the program, you got it, and then just close the hint, close the old program, write it fresh, see if you can figure it out from scratch. So that way, as long as you can write it all, the whole thing from scratch by yourself without looking at any other hints, you're good. You're welcome to look at your old programs. That's a good thing to do, right? You don't have to sit there and memorize, oh, how do I do input? That's what the old programs are for. So look at your old code, but as far as solving new problems, then try to solve it on your own. Anyway, so what is repetition? I have a couple of links in there, so I'm just going to look at them myself. All right, and not a whole lot, so yeah, why don't I just get started with let me open this thing on the side. Okay, so repetition is, I'm going to open a new window here, is a way for you to make your program repeat something a bunch of times. Okay, so generally speaking, let me save this as lecture 09, what's today, 21, time's approaching 2017. Okay, so repetition or loop or loops is a way for your program to repeat something. Okay, simplest way to put it. So if you know how many times something will repeat, right? In other words, let's say, for example, I want to make the numbers, let's just leave it like that for now. So if you know how many times something will repeat, use a for loop. Okay, and what is a for loop? For loop is something like this. For some kind of variable in range, let's say from 0 to 3, steps of 1. And by the way, notice how as soon as I start typing these things in, Python, the idle, shows me kind of what the format for this thing is. Okay, so basically it tells you that there's a couple of ways for you to do this, right? You can give it a stop value. So if I know this thing is going to happen, like let's say I want to repeat something 3 times, right? 3 times. I can do it a couple of ways, and that's just looking at this thing that shows up. So the first way to do it is it just tells you, you give it a stop value. Okay, so I want to do it 3 times, 3. Okay, and then I go and I show you print variable equals variable, and I spelled it wrong. Okay, and if I run this thing, it shows this. So what happens? It starts at 0 and it goes to 1 less than this value, and it happens 3 times. Okay, so this is a loop that happens 3 times. Loop that happens 3 times. Okay, so this basically shows you 0, 1, 2. Okay, I can do this another way. I can grab this thing, I can paste it in there, and I can just say variable is variable plus 1. Okay, if I run that thing, let me put a print in between. All right, I run this thing now, and it shows you 1, 2, 3. So you can do that, no problem. Okay, so this one shows you 1, 2, 3. Okay.
So it always starts at 0.
Always starts at 0. Okay, you could change that, right? So this is if I just do the, if I do this, if I follow the first one that it told me. Okay, so now I'm gonna do another one. Okay, so I'm gonna do print for some other variable. I'm gonna make another variable, called it I in range, and the name of the variable that I'm choosing here is whatever I want, whatever makes sense. Okay, maybe if I want to show the years from 1 to 100, I'll call the variable year. Let's call it a year. Okay, for year in range, so let's say I want to show the years from 1 to 10, right? So I want to show, let's not go 1 to 10, let's do 0 to 10 first. 0 to 5, 4. Okay, so then what I'm going to do is watch how it guides me through this thing. So now I'm going to use the second one. So it says start, stop, and there's like square bracket, step. So this basically tells you that you can give it a start and a stop. So I know it's going to go from 0 to 4, right? So that means I'm going to go from 0, let's just try it first, 4, and I'm just going to leave it like that. Okay, so that's the second one. Okay, I can do it this way, and I'm going to say print year equals year. Okay, run this, and now I get 4 years, but I'm not getting from 0 to 4, I'm getting from 0 to 3, so how can I fix this? I want to go from 0 to 5. I mean 0 to 4, not 0 to 3. Alright, so I just change this thing to 5. Okay, then I run this thing again, and now it goes from 0 to 4. Okay, so that's if I do not provide so now let's do the other one. So let's say I want to show the years 0 to 4 all the way to, like, maybe I can go to as far as I want, but let's just go to 6. Okay, so I'm going to go show every 2 years. So I go to same thing. Let me grab this here. Okay, I'm just going to grab I'll type it. So I go 4 year in range, still wants to start at 0. Oh, let's just do it a little slower. So now what I'm going to do is, so if I provide start and a stop, it assumes that the step is 1, right? So this here, this assumes step is 1. Okay, this one here assumes that start is 0 and step is 1.
What do you mean by step?
So watch, if I start typing this, it basically wants 3 values. Or you can give it one value, one value. If you give it one value, that's just a stop value. If you give it 2 values, start and stop, 2 values, giving it 2 values here means that I'm giving it a start of 0 and stop of 4. Right? So actually this one is 0 to 4. So this is start is equal to 0, stop is equal to 5, and step is equal to 1. This one is the assumed, right? Because I did not provide it, right? Because I did not provide it. Okay? And similarly to this one right here, start is 0, stop is 3, and this one is also assumed now. Sorry, start is 0. That's the one that's assumed because I did not provide it. Okay, so if I provide just one value like I did here, that means I'm providing the stop. It will stop at 3, and then the loop will assume that I want it to start at 0 and go to 1. Okay, if I provide 2 values, that means that I'm giving it the start and the stop, and the step is assumed to be 1. We're going to increase by 1 every time. I can also provide all 3 things, right? I'm going to go in there. Let's say I don't want to start at 0. I want to start at 2. Okay, so I'm going to start at 2. I'm going to go to 8, and I'm going to do 2. Right? So that means, well, maybe I should start this at 4. This is 4, then 6, then 8, and let's say I want to go to 10. Oops. 6, 8, 10, right? That's what I want. So then I'm going to start this thing at 4. This thing is going to go to 12, and then I'm going to tell it jump by 2 every time. So it's going to go 4, 6, 8, 10. It will stop at 1 less than 1 step before the last number that I entered. Okay, so that means that here now I want to do, that's what I'm doing. So my start is 4, my stop is 12, and my step is 2. Okay, so I'm going to go in there and type this thing in here again. And try it again. And 4, 6, 8, 10. That's what I wanted. Yeah? Okay. So So generally speaking, if you know how many times the loop will repeat, if you know where it starts and it stops, use a for loop, right? So if you know where the loop will start and stop, use a for loop. Okay? And of course, it makes sense to know the step. So basically, you know the stop, the start. If you know the start, stop, and step, then you can use a for loop. Okay? I can make this loop go backwards. So let's say I want to go, I'm going to grab this thing here, paste it. So now what I want to do is I want to go 10, 8, 6, 4. I want to go backwards. So now my start is going to be 10. My stop is going to be what? 2. And my step is going to be what? Negative 2. Okay? So I go in there, change my start. And I can provide variables too. I can just go, let's just take these comments out. Whoops. All right? This, that, right? And then I'm just going to go in there, I'm going to change these two variables. Start, stop, step. Okay? And comment should go there. Right? So if I run this, now I should get 10, 8, 6, 4. Run it. And 10, 8, 6, 4. Okay? So that's basically a for loop. Now there's another kind of a loop, is basically a loop that happens as many times as the user wants to. So I'm just going to grab this thing here. And there. All right. So now what I'm going to do is loop that happens as many times as the user wants to. All right. So I go in there, and instead of a stop, just a fixed number, I'm going to say something like int input, how many times do you want to repeat? And start, I'm going to change it to, let's say 0. This is going to go 1. And I'm just going to go in there, and that's it. Basically, the rest stays the same. So I'm just going to change this to, let's say, times. Time. All right, or maybe times. All right, time's good. Okay, so if I run this thing again, run it. Then let's say I want this thing to happen 3 times, 0, 1, 2, right? Another way to do this is basically you already saw that I don't even need to provide the start and the stop. I can just go in there and I can get rid of this. I can get rid of the start because it will assume the start is 0 and step is 1, and I can just go get rid of this and then make just this loop with a stop. Okay, and then maybe this time I want this thing to go to show me the numbers 1, 2, 3 instead of 0, 1, 2, right? So I'm going to run this, and I want this thing to happen 3 times, 3 times. Okay? So again, if you know how many times the thing's going to happen, if you know where it starts, if you know what the step is going to be, if you know where it's going to stop, use a for loop. Any questions? That's pretty much all I can tell you as far as for loops are. And you can have a for loop inside of another for loop. Those are called nested loops. So I can go in there and I can have for something else. Right? So I guess let's have a look at that real quick, just for a second. Okay, so now what I'm going to do is loop inside of another loop. Okay, so what I'm going to do is I'm going to do this. I'm going to say, all right, for I in range, and I'm using I because I is stands for iterator. It's a very common used variable for loops, I, J, K, X, whatever, right? But I is very, very common. So let's say I want this thing to happen from 0 to 3, steps of 1. And by the way, if you want to write it with all the 3 every time, that's fine too. I actually do it that way. Okay. So basically what I'm saying is if you want to provide the 3 values every time you write a loop, that will actually kind of teach you how to translate the skills that you acquire in this class easier into other programming languages. Because if you go to Java, if you go to C++, which you have to after this class, that's the idea, right? You take this, then you take those other ones. Those loops will require you to put a start, a stop, and a step for every loop, right? So Python is just kind of flexible and forgiving and allows you to do things easier or in different ways, but some of these other languages are kind of fixed, okay? Or at least not the same syntax. All right, so this one is going to be I is equal to just I, okay? And then underneath it, I'm going to say for j in range from 0 to 2 steps of 1, print j equals j. Okay, so this is nested loops. Nested loop. So how is this going to work? Okay, so first this loop is going to happen 3 times. And every time this loop happens, the one inside of it is going to happen 2 times. Okay, so why don't I have a look at this thing? So I'm going to run this. And in fact, why don't I do this? I'm just going to go and I'm going to comment all these other loops from before. All right, start it all the way here. I'm going to take them all out because I don't want to see all this stuff anymore. For now, at least. Okay, run it. All right, so see what happens. Initially, I is equal to 0. That's the first time. The first time we go through this loop, I is equal to 0. Then I have these two. It would be nice if I select it. All right, these two are basically this loop, right? So this loop happens 2 times. Then we're done with it. Then we go back and we go the next I on the other loop, which is this I right here. So I is equal to 1, and then underneath it you can see 0, 1. So that means this other loop happens 2 times. When this one's done, we go back. We change the I is equal to 2 now, which is the last time this loop is going to happen. And then underneath I is equal to 2, you can see there's a 0, 1, which is basically this loop happens 2 more times. All right, so that's how nested loops work. That really is about all I want to tell you as far as loops are concerned. Okay. So now that I told you everything I want to tell you about as far as the for loop is concerned, okay. Now what I'm going to do is I'm going to make a loop. I'm going to rewrite all this stuff that I did using a while loop. Okay. In fact, I'm not going to rewrite all of it because it's too much writing. Okay, but I'm going to rewrite some of them, and you're going to see that unlike the for loop, where the start and the stop are assumed sometimes, right? Like in this case, I'm assuming what the start is, and I'm assuming what the step is. In the while loop, you have to provide those every time. Okay, so for the purpose of that example, I'm just going to go in there, and I'm going to go in here. I'm going to rewrite the above using a while loop. So basically anything that you can do with a for loop, you can do it with a while loop. Except the while loop will require like 2 extra lines of code, versus in the for loop you can just write it all in one single line. Okay? So what I'm going to do is, in fact, why don't I move this? Yeah, I'll leave it like that. So I'm going to do this. I'm going to say year is equal to 4. And then I'm going to say while year is less than 12. And then in here, I'm going to show you right? So I'm going to label this a for year. And the other one, I'm going to call it a while year. While year. Okay? So that's how I would write it. In fact, let me leave it like this so that it messes up so you can see it. So I didn't provide a step right? So I actually forgot this piece. I forgot to tell the while loop by how much to increase year every time. So if I run this loop, what's going to happen is year starts at 4, and this thing goes on until year is no longer less than 12. So it goes on while it's less than 12. But I'm never changing it. So it'll just show me year 4, year 4, year 4. So I'm going to do this just to show you what's a never-ending loop. All right? That's a never-ending loop. Okay? It will go on forever until you exhaust the system memory, until the operating system kills it. Right? So I'm going to stop it. If you have a never-ending loop, you do Control-C, just like you would copy things on Windows. And it is Control-C on a Mac too, so the actual Control-C, and that kills the program. Okay? So that's that. And so let me go and fix this thing. So I guess this is, let me just leave it. So this here is, this is a example of never-ending loop, right? We forgot to provide or change the year. Okay, so that's that. Now the next thing that I'm going to do is I'm actually going to fix it. So I'm going to grab this thing, I'm going to copy it, throw it in here, and all I got to do is I have to say year is equal to year plus 2. Another way to write it is, remember your accumulation that we were looking at earlier? I can say year plus equals 2. And that's what I was telling you, that it's going to, you're going to need to know this rule. Okay, so let's see if the while loop works the same as the for loop for the year. Yes. All right, so these two, you can see that they are the same. Okay, this is the same as this. Okay, so I'm going to kill this thing again because I don't want to enter things. Control-C. So anytime you want to basically stop your program while it's running, you do Control-C and that kills it. Okay. And that's how it works on Linux computers. Linux, Unix, whenever you're like in the command line, you have something running, you want to stop it, Control-C stops it. Right? So if you're working on some kind of a server or whatever and you're on a Windows computer and you're trying to highlight something and copy it, that's not going to highlight and copy. It's going to kill the program. Okay? I think you have to do Control-Shift-C or something like that. There's like a special combination for Windows. If you're on a Mac or a Linux, it works just fine. Okay, all you got to do is the Command C copies, Control-C kills. But you don't copy on a Mac or Linux. Well, maybe on Linux you do. Using Control-C, you do Command-C. So anyway, on a Mac, Control-C kills it, just like Windows. All right. So next thing is I'm going to write this one. So I'm going to write this using a for loop. All right. So I'm going to grab this thing here, copy it. And I'm going to put it, so yeah, I'm going to put it right here. Get this, put it here. Okay, so I'm going to use the same thing that I used here. So I'm going to say all this. Well, I can just copy it again. Not that I have to, but I will. Okay, so I'm going to paste this stuff here. So same thing, year, while year is less than, stop, and starts at 10, we're stopping at 2, we're going backwards, so I'm going to say year is equal to year plus step again, right, which is another way of saying basically year minus equals 2, okay, so that's the same thing, also known as year is equal to, or plus equals minus 2, I guess. Not sure if they'll let you do that, but let's just leave it as the first one. Okay, so that's that. And then when I run this thing, it should work the same exact way as the for loop here. Okay, so this is a for year again. Run it again. And now you should see the thing work the same way. Backwards, right? 4, 6, 8, 10 with a for loop, 4, 6, 8, 10 with a while. Okay? So basically the same thing that you could do with a for loop, you can do with a while loop, but it pretty much requires an extra line of code. Okay, sometimes in a for loop you can assume what the start is. In a while loop you can't, and in a for loop you could assume what the step is, right? In a while loop you can't. You have to provide it. If you don't, you get a never-ending loop. Okay, so these are basically all the things that you could do with a for loop. You could do the same with a while loop. Okay, and you might ask yourself, well, what do I need a while loop for? Because there's some things that you can't do with a for loop that you can do with a while loop. Okay, so even though you can replace every for loop with a while loop, you cannot replace every while loop with a for loop. Okay, so what I'm going to do is I'm going to take these out. I want to do them again. I'll just take it from here all the way to down there. So stop this thing here. From here to there. All right. That way I don't see all that stuff, just a little bit of it. All right, good enough. Okay, so now let's see some examples of using a while loop to validate user input. Okay, so let's say you have some kind of an age, and of course the age is going to come from the user, like input, oops, and you tell them please enter age. And then remember you had something like if, let's just start simple. So if my age is less than 0, I tell them something like, oh, print, or let's do this again. Okay, please, no, I'll say invalid input, and then please enter age, okay, positive age. Okay, what's the problem with this is that if I run the program and somehow I get it wrong multiple times, the program only will ask me or tell me about that it is an invalid input and ask me for another age one time. Okay, so this happens one time only. Okay, so how can I change this? Well, let me take this out just so you can see it. All right, so this was it. That happens one time only. But if I want to, all I got to do is change my if to a while, and now this happens until the user gets it right, until the user enters a positive number or 0. Okay, so as long as it's not less than 0, as long as it is less than 0, we'll keep going. Anything other than less than 0 will stop the loop. So if I run this thing now, all right, -9, -9, -9, -9, -9,999. It will go on forever until I give it a good value. Okay? Now, remember that we also had, you could do, I have a typo in there. You can also do ORs. So, right, this was one example. And another example was basically, I had if age is less than 0 or age is greater than 123, I say age is equal to one of these. Alright, invalid input, please enter age between 0 to 123, right? And of course, maybe I should have an age input first here. Alright, so I'll run this again, and I give it a negative, or let's go with really big number, goes in there, negative, really big number, whoops. Oops, duh. I forgot to make it. Oh yeah, so this is an if, so duh, it happens only one time, right? If I mess it up twice, oops, program broke, maybe. Okay, so how am I going to do it? I change this, so this happens, again, happens one time. Alright, but if I want to, I just grab this thing here. And this one now if I change this to a while my age is less than 0 or age is 123, this one happens until the user enters a good number. Okay? And I'm still not all the way done with it, but you'll see. So now, if I run this, it will basically work just like an if, but it will keep going on forever until I get it right. So now I do a big number, a negative number, right? Really big number, good number, and then it's good. Okay? So that is one example of input validation. So that, I guess you could say, is input validation, right? Make sure user enters a good value. Okay, but I could still make this thing break, right? So let's just assume that I'll leave it like that. So I go in there, I run the program, and remember, so I'm going to trigger the while loop, right? Now I'm in the while loop. But if I give it a negative number, if I give it a really big number, it works like a charm. But what if I do like 3.14? Oops. Now I broke it. Okay? Let me try it again and give it some other stuff. Alright, so let me trigger the loop. I go in there and whoops, I broke it again. So how am I going to handle this kind of stuff? Fortunately for you, there's a very easy way to do it in Python, and that is using this, well, first of all, I got to tell you about the truth. So I'll show you how to handle this in just a second after I show you something else. Okay, so only works for numbers, right? So this thing here only works for numbers, right? And we'll show you how to handle the error in a bit. Okay, so I go in there and I am going to first show you a loop that goes on forever again, just a different kind of loop. So I'm going to take this out because I don't want to enter things again. So I go in there and I do while true, right? So this is a loop that happens forever. Never ending loop, right? And in there I do print hello, and if I run this thing, it goes on forever. Okay, kill it. So in this loop, what I'm going to, in this kind of a loop, right, what I'm going to do is I'm going to use this right here. I don't want to type it again, so I'll just copy paste the whole thing. Okay, well actually hold on, let's back up a little bit. So how would I stop this loop, right? So let's a loop that happens forever. So this is basically a loop that goes on until the user enters a certain value. Okay, so I guess technically you can basically rewrite this loop on top, right? So this thing that I had on top, I'm just going to grab it, copy this, put it here. So this loop goes on forever, but in it I'm going to have if this thing is, if the age is actually bigger than 0 and my age is less than 123, then I'm going to break this thing. Okay, and what does break do? Break stops the loop here. Okay, so if they enter a good value, which is between 0 and 123, I break. I stop the loop here. Otherwise, underneath it, I'm just going to have this there. Okay, so if it's a good value, stop. Otherwise, just go and ask for another thing. Okay, so run this again. -9, -9, -9, 9 stops. Okay, so this basically works the same way as the one on top. pretty much. Okay? But the trigger is the user enters a specific value and then you break the loop. And it's pretty much just like rewriting this in another way. Okay? But you have, so this one here, by definition, the loop goes on forever until you enter a certain value. And what that value is going to be is up to you. You can have an and in there. You can have just a single if. Maybe if they enter the 0, break. Right? Okay, so now that we know the while true and the break thing, then I'm going to do this error exception that I showed you. Okay, so basically I'm just going to grab this thing here, paste it. Okay, so I have a while true, and I'm going to have this business. All right, this one is the real user input validation. Okay, the other one was, you know, it works, but it works only if they enter a number. This one's going to work for anything. Okay, so what happens here is we're going to try to get the user to enter something. All right, and this here happens is, so basically instead of, what I'm saying is, where's that other error that I had over there? Right here. Right, so instead of getting this kind of a, you know, red text, a wall of red text, which may or may not mean anything to whoever's using the program. Maybe if you know Python, if you've been doing Python, hey, it makes sense. You enter the integer, you know, you're supposed to enter an integer, but the user didn't enter an integer. They entered this nonsense. Okay, so but maybe whoever's using the program has no idea about Python. So what we're going to do is we're going to override this error message. So when is this error message generated? Whenever there is a value error. So that's the error. It's a value error, which is why here I'm basically saying, okay, try to do this, and if it's a good value, I mean, if it is a bad value, right? So basically I'm kind of rewriting this in a slightly different way. So this one said if it's a good value, break. This one says if it is a bad value, continue. So what does the continue do? Continue makes the loop go back to the beginning and resume whatever it did. Right? So as soon as I hit the continue, goes back straight to the beginning and it tries to do it again. If I try to go in there and enter like a text instead of an integer, or if I try to enter a decimal number instead of an integer, that will trigger my value error. Okay? And what happens with the value error? Well, as soon as I get the value error, I'm not going to show this wall of red text, right? What I'm going to show is I'm going to show this message right here. I'm going to say you did not enter an integer. Try it again. Continue. So that means try this thing one more time. Okay? Try it. Let's see if it works. All right? So I'm going to give it the initial one. This one has to be an actual number, right? If I mess this one up, that one's going to be, you know, that's going to give me issues. Okay, but for now, let's just keep it simple. -9. I'm in the loop, right? Now in here, I'm going to go and I'm just going to give it, like, just go -3. No. Text. You did not enter an integer. So instead of getting that error message, now I'm providing the user with a more meaningful, you know, information, more meaningful prompt. They know what to do. Did not enter an integer. Try again, right? Then I try to give it a 3.14, which also broke the program earlier. No, you still did not enter an integer. Try again. Okay, integer. And then it stops. And that's input validation. Okay, and that's pretty much all you need in Python. It's a lot more complicated in other languages. Very easy to do in Python. Any questions? All right, let's see if anything else I want to tell you. And accumulation, and the nested loops, sum, count, min, max. All right, these are the hints for the other ones that are coming. Okay, so what I'm going to do is I'm going to take this out too for now. You can uncomment it later. And let's say I want to, what example do I have in here? Yeah, so let's say I want to find the sum of x numbers entered by the user, right? So what's x? Well, the user is going to decide it. So x is equal to int input, how many numbers would you like to enter? And then for, because I know how many times the loop is going to happen, it's going to happen x times. I'm going to say for I, let's just say, yeah, I in range from 0 to x, steps of 1. And I'm going to tell it num is equal to, let's go with integers. I'll tell them, please enter number, and then here I'm going to say %i. Let's just say this. Call it k. Alright, that'll be k. So you don't think it's the same. So please %i. What does %i means? We're going to insert an integer here. Which integer am I going to be inserting? The k. Okay, and maybe I don't want to insert the k, but I want to insert k plus 1. Right? So basically, instead of telling the user please enter number 0, right? And I'll throw this little column right there. Right? So instead of telling it please enter number 0, number 1, number 2, it'll tell it please enter number 1, number 2, number 3. Okay, it won't start at 0. Okay, so run this one more time just to check. Like anything you do, once you write a couple lines of code, and at least when you're new to programming, you write a few lines of code, test this thing, see if it works. If it doesn't work, fix it. All right? Oh, see, I messed something up. What's wrong with this code? Can you tell me? What is it complaining about this line? I have 1 parentheses, 2.
You're missing the parentheses.
Why I'm missing 1 parentheses? Why? Because I have 1, 2, 3 open here, and I only have 2 closed here. So I'm going to go in there, close that one. Okay, try again, and that was perfect timing for me to forget to do something, right? So how many numbers do you want to enter? 3 numbers. Enter number 1, 1, 2, 30. Okay, so now what I want to do is I want to find the sum of these things, right? I go in there, I'm going to say sum all is equal to 0, just like you did with one of these earlier assignments, I hope. And then I say sum all plus or equals sum all plus the number. Okay. Maybe I want to do, I want the sum of the negative numbers. Alright, so I go in there and I say, alright, well, sum neg is equal to 0. And unlike the sum all, where I'm always adding a number into it, in the sum neg, I'm only going to add it if my number is less than 0, if it's negative. Sum neg is equal to sum neg plus num, right? Also known as sum neg plus equals num. Same way, 2 different ways to write it. Same things, 2 different ways to write it. Okay, so now this is going to find me the sum of all the negative numbers. Okay, if I wanted to find the average, that's easy. Print the average is, and I do sum all divided by what? X. I don't know how many numbers they're going to want to enter, so it's x. X is how many numbers they're going to enter. Okay, that's my average. Okay, so sum positive, similar to the sum negative, except you just flip this thing around, only if it's a positive number. Okay, so now other things. So now you know how to do the sum of positive and negative numbers of any number of numbers that the user wants to. Now what I'm going to do is I want to find the smallest value. Right? Let's go with smallest and largest. Okay, so how am I going to do the smallest and largest? Well, we're going to have to come up with some kind of an algorithm or some kind of steps that we need to follow to solve this problem. So, algorithm to find the smallest. Okay, it goes like this. Make a variable smallest equal to the first number that was entered. Okay, then if any other number after the first is less than smallest, then 3 or 2b, I guess, 2b, all right, then that is your new smallest. Okay, in other words, let's say I have numbers going like this: 4, 3, 2, 1. Right? Suppose the user wants to enter 4 numbers. These are the 4 numbers that the user entered. Okay, so what I'm saying is I'm going to make a variable smallest equal to this thing. So smallest is equal to the 4. Okay, initially. Then I'm going to say, all right, hold on. Well, is this number, is the 3 here less than smallest? Well, yes, it is. So basically, it goes like this. So is 3 less than smallest? Right? Yes. So smallest is equal to 3. Then I go to the next one. Is 2 less than smallest? Right? Yes. So smallest is equal to 2. And then the next one is, the last one, I guess. Well, you can stop in there if you want. But let's do 1 and then a 10 at the end, right? Is 1 less than smallest? Right? Yes. So smallest is equal to 1. And then the last one is 10 less than smallest? No. Right? So smallest is still 1. So it goes through these, picks out the smallest, and keeps it. So that's what we're going to do. And then whenever you're trying to come up with something like this, you know, you're thinking about some kind of a problem and solution for that problem, it is very easy for you to just, you know, start with something simple. Start with like 3, 4 numbers. Try to visualize, write out the things that need to happen, just like I did. And then from this, write the code. Okay? So I guess the one question I have is, or one of the main things that I need to do is basically, how am I going to make a variable smallest equal to the first number that was entered? So my question to you is, how can I know that num is the first number entered? So how do I know it? How can I identify that they're entering the first number? All right. How can I identify that the user has entered the first number? That's my question for you. And help me out. What tells me that I'm going through the loop the first time? Little clue. These are the values of k. K is going to go k equals 0, 1, 2, 3, all the way to x minus 1, right? So how do I know we're going through the loop the first time? What's the value of k the first time we go through the loop? 0, right? So if k is equal to 0, right, this means this is true the first time when we go through the loop. Okay, so the first time we go through the loop, make num is smallest, a variable smallest, is equal to num. So smallest equals the first num that was entered. Make sense? Any questions? Okay. What if I had this thing like this? 1 and x plus 1. So I can do it this way. What will be the first time I go through the loop then? 1, right? So if I had this kind of a loop, the first time we go through the loop, so this thing is going to go 1, 2, 3, etc., etc., etc. All right. So the first time I go through the loop, it will be when this thing is 1. Okay. But so.
But will there be negative numbers?
Sure, you can have negative numbers. K is always going to be these numbers, 1, 2, 3, all the way to x minus 1. Num is just a number that the user enters, and that could be whatever they want. Okay, so I'm gonna go back, reverse this thing to 0, just to stay with what we had originally. All right, so 0 is the first time we go through the loop. So smallest is equal to num. So I basically took care of this first step. Make a variable smallest equal to the first number that was entered. Next one. If any other number after the first is smaller, is less than, right? Less than smallest, then that is your new smallest. So how do I do this? So I'm going to do this. First, I'm going to say else, right? Which is basically, this happens for every number after the first, right? So if this is true the first time we go through the loop, this happens for every other time that we go through the loop, right? For every other time we go through the loop after the first, right? So I go in there and I do, okay, well now if my smallest, or no, if any of these numbers, if any number is smaller, so if num is less than my smallest, then smallest is equal to that number, or that is my new number. That is my new smallest. So smallest equals that number. Make sense? That's it. So that's basically the little steps. Come up with some kind of an algorithm. Think about it. Maybe you want to write out the numbers first and see how you're going to go about this thing. But the bottom line is this. The computers can't just eyeball 20 things at the same time the way we humans can, right? Well, the only thing they can do is they can compare only 2 things at a time. That's how the processor works. You grab one thing, you get another thing, you compare the 2 things to each other. Maybe you can throw an and an or in there, but fundamentally, what is a condition? The way we check to see if something's true or false is just between 2 different things. So we're limited to that, which is why we create a smallest, make it equal to the first one, and then compare that smallest to every other number. If any other number is smaller, that's your smallest. Okay? So that's how you find the smallest. That's how you find the sum neg, and that's how you find the average. What do you think you're going to do for largest? It's the same exact thing, right? You basically, it's the same algorithm. We're going to make the variables largest, right? Largest is equal to the first number that was entered. And then, if any other number is greater than my largest, then largest, if you could spell it, is equal to that number. All you do is you just flip this around. Okay? But the rest of it still applies. Make sense? Okay, so let's check. Print. And by the way, I did a whole lot more than I should have. By that, I mean, when you're writing your code, remember, test this thing, see if it, first I should have tested to see if it works for sum, if the sum works. Then I should have tested to see if the sum neg works. Then I should have tested at least for my smallest to see if it finds my smallest, and then write the largest and test again. But since I'm so confident in my abilities, let's just do it all at once. So largest is largest. So I go in there, run this thing. So I want to enter how many numbers? Let me try to simulate this thing, right? So this thing here has what? 1, 2, 3, 4, 5 numbers, right? So I'm going to go, did I go with smallest? Let's go smallest. So I want to find smallest, because that example was originally to find smallest, right? So smallest should be this number right here, somewhere towards the middle. I didn't want to go the largest, because then you might think that, well, it's just getting the last number, which it doesn't. Okay, so I want 5 numbers, and I'm going to go in there. I'm going to enter these 4, 3, 2, 1, 10, right? 4, 3, 2, 1, 10. All right. Largest is 10. Why am I still showing the largest? What the hell? How did that work? Maybe I didn't save it. 5 numbers. And what are the 5 numbers? 4, 3, 2, 1, 10. There you go. Here's your smallest. So I guess we tested it both ways, right? Average is still the same. You can find your sum. You can find your average. You can find the sum neg. Okay. So that's one of the important pieces of the puzzle that you should know for this class. I want you to know how to look through a series of numbers and finding the min and the max and counting them and that kind of things, right? That is basically your. I guess I did more than I was supposed to for this week. So this is more about, this is more of a topic for the next week that I was going to do. Okay, so I'll leave it there, and then I'm just going to start with these assignments, give you some hints, and then we're done. So the first one is conversion table. All right, conversion table. You're going to have a bunch of kilograms on the left, and you're going to have a bunch of pounds on the right. In case you don't know, 1 kilogram is 2.2 pounds. So there you go. 1 is 2.2. Then when you have 3 kilograms, it's 3 times 2.2, which is 6.6. And you're supposed to go in there and do all this for all the different pounds. Okay? So just a little hint, right? There you go. So let's do, this is your hint for, I'm going to take this out because I don't want to type things again. All right. So this is P16 hint. All right, so let's do some kind of a unit or currency conversion. Give me a currency. Rubles. Damn it, man. You just had to go Russian on me. All right. Ruble. How do you spell that damn thing? Ruble. I don't know how to spell it. Ruble to USD. Good. It's not worth anything. All right, that's the way it should be. So it's 1 Russian ruble. Ruble is 0.017. That's how you say it, ruble in Russian, whatever. So anyway, I'm not Russian, by the way, in case you're wondering. So 0.107, 0.017. Okay, I'm gonna copy this thing. I wonder how much is it peso? Peso to use. Is it more than that? Peso is more than the ruble. Awesome. I love it. Okay, so yeah, sorry if anyone is Russian is watching this. No, I'm not really. Okay, so paste. So this is 1 ruble is equal to this many USD. That makes sense? Or no, it's the other way. No, that's right. That's correct. All right, so 1 ruble is this many USD. Okay, so what I'm going to do is I'm going to have rubles on the left. So I'm going to say, all right, so let's say I want to show rubles from 1 to 100 like this. I want to show them like 1, 11, 21, right, all the way to like say 91 or something. Okay, well actually, why don't we just do this? 10. Nah. I'll start at 0. 0, then it's going to be 10, then it's going to be 20, and all the way until it goes to 100. Okay? So I know how many times this thing is going to happen, which means that I could use a for loop, right? I could use a while loop, but it would just be better programming practice to do it with a for. Shorter, better code. So for, I'm going to call it what it is, ruble, in range from 0 to, I want to go to 120 in steps of 10, right? And then first thing I'm going to do is I'm going to just check this thing, see if it works. Ruble equals this, right? All right, it does what I want, right? It goes from 0 to 110, 110. Wait, that was supposed to be in steps of, so 110. Right? So that's why you want to test it, because these mistakes happen all the time. So now I fixed it. It should go from 0 to 110 or 100. Okay, next thing I'm going to do is, in here, I'm going to do right on top of it, I'm going to say USD is equal to ruble times 0.017, right? And then right next to this thing, I'm going to say, all right, well, USD equals USD, right? And I'm going to run this thing again, and you're going to see how worthless the ruble is, really. If you get 100 of them, you get $1.7, and you can buy yourself, I don't know what, bag of chips. Okay? So, but what I want to do is, I don't want to show these labels right here, okay? Because that's a whole lot of labels. What I'm going to do is I'm going to put the labels on top, right? And then the numbers are going to be just in columns underneath them. So what I do, I'm going to put a print in here, and I'm going to grab this stuff, cut it, paste it, grab this stuff, cut it, put a little space, paste it, and I guess I could just erase this piece here now. And I'm going to put a little space in between, right? And I'm going to run it again, see how it lines up, correct some things maybe, like right now, right? And kind of, right? Maybe I want to move them a little bit to the right, right? Let's do 1, 2, 3. Try again. No, let's not do 3. Well, yeah, let's do this. All right, good enough for now. So notice one thing that's happening, right? These numbers here are kind of lined up. All right, what I'm talking about is, see how there's like a shift right here from this one to this one on top, and then here there's another shift, right? Why is this shift happening? Because we have an extra digit here. So here we have 1, here we have 2 digits, and as soon as you get to the 2 digits, this is forced to be shifted 1 to the right. Same thing happens right here. I have 3 digits, which is more than the 2, which is why you see this little shift here. So the next thing I'm going to do is I'm going to tell it, all right, hold on. I want, whenever I show these numbers here, all of them, show them with 3 spaces reserved for them. So I go in there, and in front of the ruble, I'm going to do %3i, right? And then percent. So what is that going to do? %3i means insert the ruble value, but reserve 3 spaces for it. And let's try this again. And now you're going to see that it's more lined up. Perfect. But now you can see some weird stuff happening here. It's showing me a whole bunch of stuff that it's not supposed to, like this stuff here. That is actually normal for these kind of discrepancies to show up. Is this the actual decimal number that I'm supposed to be getting? No. This is called, well, there's an issue when we convert decimal numbers to binary numbers. And since the computers work all in binary, we cannot accurately represent decimal numbers with binary. Okay, which is why you're getting these like trailing errors at the end. Doesn't matter. What I'm going to do is I'm going to say, all right, I'm going to round these to 2 decimals, right? I only want up to the decimal, 2 decimals for the dollars. So I'm going to go in there. I'm going to say, okay, %.2f. Run this again. And, oops, I forgot to put percent here. And that's why you want to test a lot. All right, there you go. Now it's rounded up. Okay, maybe I want to shift this thing a little more, make this a 4i. All right, reserve 4 digits for it. That way the whole column gets shifted a little bit to the right, hopefully, and there it is. Okay, you want to move these digits to the left. You go in there and you do, I think it's minuses, right? Percent minus 4i. I think that's where the minus is supposed to go. And yeah, then it still reserves 3 spaces or 4 spaces, I told it. Right? It's actually reserving 4 spaces, but it's just shifting, aligning them to the left. Okay, if you don't have a minus, it basically assumes a plus. Right? So I'll just leave it like that. So I'll go back to 3. Okay, and I'll add a little extra space in there. So that's your P16 hint. I'm going to take this out so we don't look at it in the shell window anymore. Oops. Yeah, go back to 17 now. Tuition table. All right. So let's say, well, this is similar. So let's say you have P17 hits, right? You have, I don't know, you have a savings account, all right? And I don't know, $100 in it. Well, let's make you a millionaire. $1 million in it. Is that it? 3, 6, right? $1 million in it, and you get, I don't know, what ridiculous interest does the bank offer? Huh? No, you wish. It's more like probably 0.0 or whatever. What is it? 0.3% or something? Let's just say it's 3%, right? Let's say you get 2% per year interest, okay? So how much money do you have over the course of, I don't know, 20 years? Okay. So, by the way, if you want this kind of an interest, you would have to put it in like some kind of a S&P 500 index or something like that. All right. There's some other ones, but yeah. And then hope for the economy to go up. If you don't know, the S&P 500 index has been averaging 10% per year for like over, I don't know, more than 100 years. That's including the Great Depression and that recession that we had, right? So if you average all that, it's still going at 10% per year. So moral of the story is you put your money there and you forget it for a long period of time, and it will basically double up every 10 years. Okay, one of the richest people in the world, Warren Buffett, that's what he said. He's going to put all his wealth into like the S&P 500 index, like 90% of it. That's all it's going to do. No, you know, what is it? Trust funds. Well, I guess that could be a trust fund, but no, just an index fund with very low interest or very low fees. Anyway, going back to this, so you have savings is equal to 1 million. 1, 2, 3, 1, 2, 3, right? And I have 4 year in range from. Let's go from 1 to 21 in steps of 1, and I'm going to do savings are equal to their own value plus their own value times 0.02. That's 2%. You could also write it as savings is equal to savings times 1.02. Same thing. Okay, so it's equal to its old value, but add an extra 2%. And then I'm just going to show you. First, I'm going to show it right here. So I'm going to say print year equals year, and then savings equals savings. Run again. And see how much money you get. Whoops. Savings. Right, so that's how your money grows, basically. Okay, but now imagine if you have it as an S&P 500 index and it's 10% per year, unless the economy crashes. All right, so that's that. So that's your hint for P17, similar to what you have to do, except here you have some kind of a tuition problem with maybe a different interest. All right, exclamation through the tilde. Okay, so I got to give you a little more information on this. So you have to show these characters. So you have to go from the exclamation all the way down to the tilde, which is a whole bunch of different characters and numbers, uppercase letters, lowercase letters that you have to show. How are you going to show these? Well, there's this thing called an ASCII table, right? And let me just save it. Well, I'll just zoom in on it. So what is the ASCII table? ASCII table is every key on your keyboard has a numeric representation. So the number 0 has the numeric representation, has the is the number 48 ASCII. So 0 on your keyboard is 48 ASCII. Uppercase letter A is 65, right? Lowercase letter or uppercase letter Z is 90, right? Lowercase letter Z is 122. Lowercase letter A is 97. So what the assignment is asking you actually is go from this one, which is the exclamation, all the way down to the little tilde. So in other words, you're going to show every symbol from the number 33 all the way down to 126. Okay? So you're going to ask yourself, well, how in the world am I going to do this? So it goes like this. So first of all, and there's some hints in there, you can look at that. All right, so let's say I have the letter A, print A. Okay, and then I can also do print, I think it's ORD, A. All right, and if I run this, see, this is the A is my letter A, or the A is the ASCII, right? So this one shows 97, which is the ASCII for letter A. Okay, I can do it the other way around. I can say print CHR 97, and this one shows A, which is ASCII 97 converted to character. So if I run it, then there you go. Okay, so what do I have to do? Let me just do a few of them. So let's say I want to show the letters. I want to say from A. I want to do A through L, letters A through L. All right, so let's do this. Want to show letters A through L. These are the uppercases, but I want to show them 4 per line. Okay, so first I'm going to do, all right, 4. Let's call it ASCII in range. What is my letter A? 65. L is 76. So 65, 76. All right. 65, 77. Steps of 1. Throw the parentheses around this thing. And then just give it a test. Print ASCII. Whoops, no label. Just ASCII with maybe a little space. And then end equals quote quote. Okay, what does this end do? Prevents it from inserting a new line every time. Okay, so I'm gonna go and run this thing. Hope for the best. So these are the ones, right? 65 through 76. I got them. Okay. Next thing I'm gonna do is I'm not going to do it this way. All right, I'm going to get this. I'm going to do the little conversion that I did earlier. So I'm going to say CHR. So force this thing to turn itself into a character. Run it. And these are my letters. Okay, so next thing is, what I'm going to do is I'm going to count every letter that was shown. So I'm going to go in there, I'm going to make a variable count. Count is equal to 0. Okay, every time I show a letter, which is what this does, I'm going to say count is equal to count plus 1. Okay, and if my count is 4, if I count 4 of them, because I said I want 4 per line, right? Which means that I counted 4 letters. What I'm going to do is I'm going to say print, write that, which is going to show a new line, and then I'm going to restart counting. Restart counting. Okay, I run this thing now, and it should show them to me 4 per line. Okay, so that's that one. Next one, 19 through, number 19 is basically the same kind of business, but now with numbers, right? So this time, you're supposed to show the numbers from 1 to 1,000, but you're going to be showing them X numbers per line. Okay, so I guess it was 17, 18. So this is your P18 hint. P18 hint. And I guess I'm going to call this also a P18 and 19 hint. P19 also. Okay, because P19 is very similar to this one, except it will go like this. You're going to ask the user how many per line they want. So the only thing we're changing is asking them how many numbers per line they want, and you already know how to show numbers per line. The only thing that you're going to have to change is you're going to have to make this thing a variable. So instead of a 4, which is fixed for this particular example, you're just going to ask the user, well, how many per line do you want? X. Okay, then change this to X. Same thing. Okay, all you got to do is have another input somewhere on top. Okay, make sense? Okay, so that's that one. Next one is sum of positive and negative numbers. I already showed you how to do that stuff, right? That was your hint number, whatever. Where is this thing here? This is your P20 hint. P20 hint. And penny or $1 million, that's a good one. So you're basically now given the problem. 21, let me double check. Yeah, 21 is the last one. So you're given this question. So you have a choice between a penny which doubles its value every day over 30 days. So you get the value of that thing at day 30, or $1 million on day 1. Which one would you choose? First one? Why is that? It's just a penny. All right? So write the program, have a look at how this thing grows, and tell me how much more is the penny compared to the dollars, or the $1 million, or how much less. So write a program which calculates exactly how much more or less you can make with the penny on day 30. Okay? And this one is very similar to, where's that other one that I did? To this one, right here. So this is P17 and P21 hint. Right? You're basically going to have something which, instead of having savings is equal to savings plus some percent, it's just penny is equal to penny plus penny. Right? Or you could say penny is equal to penny times 2. Right? Same thing. Very similar. So the nice thing, the best thing to do is just show yourself the penny for every day of the 30 days so you can see what the value is. If you want to know how to round these things nicely, how to format, because you're going to get you might end up getting a really big number with a penny. You could start the penny at, so use penny is equal to 0.01, right? Don't start it at 1, start at the actual dollar value so that it shows. So then you go to week 1, and in week 1 in the output you'll see that they have another way for you to format your output, and that is using this notation right here. So that will allow you to basically get a really big number like this and show it with a comma separator, and you can also round the decimals down too. Okay, so I would suggest you use this one for the penny problem. Questions? We're good? Alright, so that's all I have for today. Let me know if you have any questions, and come